This is a system that we're building at the Harvard Graduate School of Education, in which we're looking at how augmented reality can help instructors to explain concepts that are difficult for physics students to visualize otherwise. In this case, we have a physical magnet, and we're going to be inducing magnetic fields and electricity into this coil. And so with this visualization technology, we can enable, for example, visualization of the magnetic field here. We can also focus the student on areas of this coil, for example, this cross-section over here. And we can show things such as the fact that when this magnet is moved closer, the magnetic field is crossing through that area. Not only that, but we can show things such as how the magnetic flux is changing in that area of space. So whether it's increasing or decreasing. So when I move this magnet, the flux is increasing or decreasing. We can also show things such as the electricity flowing through this when it's being induced by the movement. So we're moving the magnet and there's electricity being induced. We can also show things such as the induced magnetic field in this coil. So there's this induced field that happens when this magnet is being moved in different directions. We can also show things such as how the magnetic field is changing in this area of space and how the induced field of the coil is opposing that. So in this case, you can see that when I move this magnet inwards, the magnetic field is increasing inward, but the induced field from the coil is pushing outwards. So you have this opposing fields going on here. And the final thing that I will show you as a quick preview is the fact that when we move these objects around, this coil actually becomes like a magnet. So I'm just going to rewind this magnet a little bit. And this visualization is going to show that when there's an induced field from the coil in this direction, the coil becomes like a magnet with a north end on this side and a south end on this side. So you can see when I move this, the coil becomes like a magnet, and it's kind of like bringing two magnets close to each other. For more information, please get in touch with us or see our lab webpage. Thank you so much.